Hello, welcome back to Lee Rogers Chemistry channel. Seems that you guys are all eager to learn about chemistry today. Well, my name is Lee Raj. Today, we will be delving into organic chemistry, specifically alcohol elimination reactions. Now, as we should know, or as we do know, the general word formula for an alcohol elimination reaction is an alcohol as a reactant, and then we have our catalyst, which is sulfuric acid, H2SO4, aqueous at 100 degrees Celsius. Perfect. And then we have our products, which is an alkene plus water. Perfect. Now in today's lesson, we will be focusing on pentan-1-ol, which is drawn as such. 5 carbons for a carbon chain, alcohol on the first carbon, and then we just add in our insignificant hydrogens. Perfect. However, before we can move on, I must tell you about Zaitsev's rule right here. You may be asking, what is Zaitsev's rule? Well, Zaitsev's rule is pretty simple. It states that when an asymmetrical molecule undergoes an elimination reaction, the hydrogen atom is removed from the carbon with fewer hydrogens to produce the major product. Essentially, the poor get poorer. Now, this rule is used to predict the product. It is instrumental in predicting the product. Now, moving back to our reaction, I'm just going to write in our catalyst, so sulfuric acid and 100 degrees Celsius. Perfect. As you know, this is an elimination reaction, so we have to cut off the bond between the alcohol and the carbon. Now, we're going to look at the carbons connected to the carbon I just highlighted, and we're going to realize that there's only one carbon connected to it, which is to the right. And we are going to borrow or steal one of its hydrogens, as I have just done. Now, to write out the product, it's pretty easy. We're going to write out our parent chain, which is 5 carbons long, and then we're going to put in our double bond, and then let's put in our insignificant hydrogens. And then we have water as well, which is created from that alcohol and that one hydrogen. Perfect. Now the name of this over here is pentan-1-ol. Then we have our reactant. Oh, sorry, not a reactant, our catalyst, sulfuric acid at 100 degrees Celsius. And then we have pent-1-ene plus water. Perfect. However, I'd like to remind you that we do have a double bond, and usually when you have a double bond, you either have a cis or a transformation. But in this scenario, the double bond is connected to a terminal carbon. As such, we have a neither formation, and we have a shape of trigonal planar on the first carbon. Now, I have a question for you. When you do an elimination reaction with pentan-3-ol, what are the products going to be? And what's the difference between pentan-3-ol and pentan-1-ol? I'm going to give you 5 seconds to think on this. Perfect. I hope you've thought about it. I'm just going to draw pentan-3-ol. I put the alcohol on the third carbon, and I've surrounded it with insignificant hydrogens. While I'm at it, I'll add our catalysts, sulfuric acid at 100 degrees Celsius. Perfect. As we know from before, we have to cut off the bond between the carbon and the alcohol. Now, if we look at this carbon, there are 2 other carbons attached to it. which I have highlighted with green. We have to steal the hydrogen or the insignificant hydrogen from the carbon with fewer insignificant hydrogens. In this scenario, both of them have two insignificant hydrogens, so it does not matter which carbon we steal the hydrogen off of. I will take it off of this carbon. Additionally, we have to add in our other bond between those two carbons, which is represented by the black dotted line. Now, we can get two possible answers from this, or two possible alkenes from this, because there can either be a cis formation, or a transformation alkene. I will draw both of them for you. This is the cis formation alkene. And this is the transformation alkene. And both of them will have water as the other product. Now, I'd like to name everything we have here. We have pentan-3-O. Then we have our catalysts. Sulfuric acid and at 100 degrees Celsius. I shall name this in green. That is cis-pent-2-ene. And then we have this, I'll name that in blue. Or light blue, there we go. And that is trans-pent-2-ene plus water. Finally, I would like to focus or explain how the first question is different from the last question, or the second question. And it's pretty easy. Obviously, we can look at the reactants. We have pentan-1-ol and pentan-3-ol. Obviously, those two are different because the alcohol is on carbon number 1 for pentan-1-ol and then carbon number 3 for pentan-3-ol. However, I really want to focus on the products. In pentan-1-ol, you get a product that has a neither formation because the double bond is connected to a terminal carbon. As such, you cannot get cis, trans, neither. You can only get neither. Whereas in the second question, you have two possibilities. You can either get cis or trans depending on how you place the insignificant hydrogens. So you can either get cis or trans. And that is because the double bond is connected to the second carbon. Now, thank you for listening. I hope you have a spectacular day.